So when we're multiplying expressions, the key thing here to remember is that because we don't have variables anymore, we kind of forget our exponent rules sometimes. But the rules are still the same. If you guys are multiplying things together, you add the exponents if they have the same base. If you have a power on the outside, it gets multiplied in. Anything that is negative gets moved to the bottom of a fraction to become positive. So if we're trying to use our properties of rational exponents and radicals to simplify multiplication problems, if we look at number 1, 6 to the 1/2 times 6 to the 1/3. If this were x and x, you wouldn't say x times x is x squared. You'd say, okay, keep the base of x, but add the exponents. So we're not going to multiply 6 times 6. We're going to keep that base, but add 1/2 plus 1/3. But we need to know how to add those together, because for fractions, you can't add denominators that aren't alike, fractions with unlike denominators. So we need to make both of these sixths. So to make the half a 6, we need to multiply by 3. To make the third a 6, we need to multiply by 2. So this becomes 6 to the 3/6 plus 2/6. So 3 plus 2 is 5. And we just can't have an exponent that is a fraction, so we're just going to rewrite this as the 6th power, or the 6th root of 6 all to the 5th power. So just by rewriting it, we're okay. We don't have that rational or fraction exponent, and then we're good. So for 2, if we've got a power on the outside, we're going to distribute that in. Just because we're working with fractions, I'm going to make the 2 a fraction by putting it over 1. And then we multiply it in. So we multiply fractions by doing numerators with numerators and denominators with denominators. So 2 over 1 times 1/2 is going to be 5 to the 2/2 times 7 to the 2/3. So 2/2 is just really 1, so this just becomes 5 times 7 to the 2/3. We're going to rewrite as the cubed root of 7 squared. That's it. That gets rid of our fraction exponents, and we're good to go. So number 3. Same idea, I'm going to make everything a fraction. So if we distribute that power in here, this becomes 2 to the negative 6/6 times 4 to the negative 6/6. So 6 over 6 is just 1. So this actually becomes 2 to the negative 1st times 4 to the negative 1st, but we can't have negative or fraction exponents. So both of those will get moved to the bottom. So this becomes 1 over 2 times 4, which is 1/8. So what if we're working with radicals? Well, as long as they're the same radicals, we can multiply them together. So if they're both the cubed root, we just make it go from 2 cube roots to 1 and say, what is 12 times 18? 216. You guys are more than welcome to factor that out. You would get the same result, but the cubed root of 216 is a perfect cube. The cubed root of 216 is 6. So that whole thing equals 6. So then number 5, cubed root of 54 times cubed root of 6. If they're the same root, you just multiply them together. So 54 times 6 becomes 324. So 324, not a perfect cube. So I'm going to go ahead and factor this. So 27 and 12. You could start with anything. You could have started with 2 and 66 or 166. But 27 and 12 will work. And then 27, 9 and 3. 9, 3 and 3. 12, 6 and 2, 6, 3 and 2. So we're looking for cubed roots, groups of 3. So I've got a group of 3s here, but then all of these don't make up a group of 3 of anything. So all 3 of them actually are going to stay underneath the radical. So the one group comes out, and we have the cube root of 2 times 2 times 3, which is 12.